Linear equations can also be written in general form, which is ax plus by plus c equals 0, where a, b, and c are all real numbers, and a and b cannot equal 0. So for instance, anything like 2x plus 7y plus 2 equals 0. You can see a, b, and c are just your numbers, your coefficients, a, b, and c. Now, if we have an equation written in general form, I can see I have a, b, and c. A is 2, b is 5, and c is negative 15. I can see all those values, but I have no way of graphing it in that form. So I could write it in slope-intercept form. Let's try to remember that's y equals mx plus b. So I can see that I have this 2x term, which needs to move to the other side. That shouldn't be here. So we'll subtract 2x, and it doesn't have a like term, so I'm just going to put it out to the side. So I see 5y comes down because my 2x's cancel, minus 15 equals, there's no need to write this 0, so I'm just going to go ahead and write negative 2x. And I still see I need y equals, so this 15 needs to go to the other side of the equation as well. It's minus, so in order to move it to the other side, I'm going to have to do the opposite to get it to cancel. So I'll come to the other side, and I see 15 does not have a like term, so I'll put it out here to the side. And I see 5y, my 15's cancel, equals negative 2x plus 15. And I still need y equals, so I still have to get rid of this 5 and move it to the other side. Right now, because that says 5 times, I'm going to divide everything by 5. The 5's cancel again, and I get y equals, m, remember, is slope, rise and run. So I don't want to divide that out and get a fraction. I'm going to leave rise and run, negative 2/5 x. And 15 divided by 5 is positive 3. So now I should be able to graph because I remember m and b. B is where I begin the graph, the y-intercept. So I go up to 3, and I'll put my dot. And then I know m is how I move on the graph to get my next point. I'll rise negative 2, so because it's negative, I'm going to fall 2, and I run 5. So I'll positive 5, and I put my dot. And again, we could repeat this multiple times, and down 2, right 5. And even if we wanted to go the opposite direction, we could do exactly the opposite. Instead of down 2, I could go up 2, and instead of right 5, I could go left 5, which will give me quite a few points on my graph, and I'll draw the line through the points. Now, if I didn't want to write in slope-intercept form, I could also try to find intercepts of the graph. So I note that the x-intercept is where the graph crosses the x-axis, and all the y values there equal 0. So I could say 2x plus, I know that y is 0, and I'm going to solve this for x. When I do, I know that 5 times 0 is 0, so I've got 2x minus 15 equals 0. And I'll continue to solve for x by doing the opposite. Add 15 to both sides, and I get 2x equals 15. When I divide by 2, x equals 7.5. So the ordered pair for my x-intercept is 7.5, 0. And let's go ahead and graph that. X is 7.5, so I know it's in between 7 and 8, and y is 0. So there's my x-intercept. Now if I want to find the y-intercept, I'm looking at this same equation, and I remember that x is 0 because it's the point where the graph crosses the y-axis. So if I fill in 0 for x this time, I'm going to solve my equation for y. I know that 2 times 0 is 0, so I'm left with 5y minus 15 equals 0. We'll add 15 to both sides of the equation, leaving me 5y equals 15. And then I divide by 5, and y equals 3. So the ordered pair, I know y is 3, and we know our x value has to be 0. So the x is 0, and the y is positive 3. And I have 2 points on my graph, so I can draw the line through the 2 points. And you can see whether I did this graph or the one before, they should match because they're exactly the same equation. So whether you graph in slope-intercept form or point-slope form, you should get the same line.